Endeavour, Houston, we see you, Dave, on the flight deck. Could you check out that fitting on the Gira for us and see if it's still leaking?
Yeah, Box, we've been watching it, and I'd say 90% or more of the leak is down. It's very low right now. When you look closely at the fitting, the exit point of the tubing from the compression fitting does not come out straight. It's maybe 8 degrees off. And, Roman and I, we've been talking about it with you, maybe not leaving it like that overnight in particular in case it would come apart. So we need to be thinking about how we want to, if we can keep an eye on it during the day. We rarely use the tube, and it's not needed at all in the night config.
Okay, we appreciate the great report, and we're glad that we've knocked it down considerably. We're going to think about it, and we'll come up with a forward plan for you.
Copy, and if you want us to take it apart and put it back together or whatever you guys want, we're standing by. But we're safe right now with it.
Copy that.
View we're seeing now is coming from one of the systems on the orbiter boom sensor system, this particular one from the laser dynamic range imager, which combines an infrared laser illuminator and an infrared camera recorder to build 3D images of the shuttle's heat shield that can be compared to images of the heat shield that were taken before the flight, so that teams on the ground can search for any differences. Orbiter boom sensor system also includes an intensified television camera, which gives the plain black and white TV views that we often see from other cameras inside the shuttle's cargo bay. And then a laser camera system, which is a scanning laser range finder that can be used as a 3D camera to create 3D computer-generated models of the heat shield. This inspection today will take about 7 hours in all if you include the time it takes to actually get the orbiter boom sensor system set up and then put it back into its place along the sill of the shuttle's cargo bay later tonight. All about 7 hours, and requires, for the most part, 3 crew members. It takes 3 because you need 2 crew members to control the robotic arms movement, and then another crew member to operate the other shuttle cameras that are being used inside the shuttle's cabin for situational awareness and clearance views. Today, the 3 that have drawn that duty are Commander Mark Polinsky, Pilot Doug Hurley, and Mission Specialist Julie Payette. Again, they're starting here with the starboard or right wing of Endeavour, and then we'll move from there to the nose cap, and then after a break for lunch to the port or left wing. As you can see, Commander Mark Polanski, pilot Doug Hurley, and mission specialist Julie Payette